So you may remember earlier in this video series, I talked about the fact that all functions do not have inverses. Let's see why not. So if we look at the graph of x squared, if I graph the inverse of this, if I reflect it, let's think about what I'm going to have. This branch on this side is going to come down here. So I had 0, 0, negative 1, 1 turns into 1, negative 1, negative 2, 4 turns into 4, negative 2. So here's my left branch. I'm just going to highlight that in blue. Let's actually erase that and highlight that with a smaller blue. Okay, let's go with green. No, green is our y equals x line. So in purple, I'll draw in this branch. So again, I have 0, 0. The 0.11 stays 1, 1. The 0.24 becomes the 0.42. Well, here's my whole inverse. And of course, my inverse fails the vertical line test. So f inverse of x fails vertical line test. So it's not a function. But if I looked at only one branch of my original at a time, then the result would be a function. If I had only one of those lines, I would have a function. So this is what we're going to do to make functions. So first of all, let's talk about this definition. A one-to-one function, so a function is one-to-one if and only if for every y there's exactly one x. So if I look at my parabola, for every y there's more than one x. So a parabola is not one-to-one. But if I looked at some of my other graphs that did have inverses, so for example, let's look only at f of x. Now for every y, there's only one x value. Same thing for g of x. For every y, there's only one x value. So these functions are one-to-one. So if a function is one-to-one, it will have an inverse. We call this the horizontal line test. If you can draw a horizontal line and hit only one point, then the function will have an inverse. If it fails the horizontal line test, that means when I inverse it, it's going to fail the vertical line test, which is how it won't have a function. So thinking about this, if I wanted to make the inverse be a function, then I could say from the beginning that f of x is equal to x squared for x greater than or equal to 0. Then I would look only at the purple, and f inverse of x would be equal to the square root of x. So then I would have a function. Or I could say f of x is x squared for x less than or equal to 0. And really I could have said less than or equal to 1 or anything, but I can go all the way to 0. If I said x is less than or equal to, negative 1 is what I meant before. If I said less than or equal to 1, then I would fail the horizontal line test again and not have a function. So we pick the maximum domain we can. In this case, if I said that f of x was equal to x squared for x less than or equal to 0, that would mean I was looking at the blue part of my original. So when I inverse that, I would have this blue line. My inverse would end up being, So my inverse would end up being negative square root of x. So this line down here is the negative root x. So x squared on its own does not have an inverse, but if I restrict the domain, I can have an inverse. We'll look at that more in the next example.